This tutorial will walk you through the steps that we need to take when we do the linear equations Desmos activity. I'm here in slide 1. It says use the sliders to determine how each variable transforms the graph. So we want to know what each of these variables do to the graph. Now I want you to look at the green point and see where the green point goes when we change these variables. So let's start with A. If we make A higher than 1, the green point goes up. So when A is 3, the green point is now at 3. It used to be at 1. Then it went up to 3. If we make it 4, then it goes up to 4. This is called vertical stretching. If we put it back to the default one, we're back to the original line or the parent function for a linear function. If we make A less than 1, then the green point is going closer to the x-axis. It is being pressed down. This is called vertical compression. Okay. Now, if we make A -1, then we have a reflection of the line over the x-axis. So we're going to use this to put a note that A is for vertical stretch, compression, and flipping over the x-axis. All right, let's put this back into the default. Okay, now let's look at B. What does B do? So again, I want you to look at the green point. As we increase B, the green point gets closer to Y, as if it is being pushed towards the y-axis. This is called horizontal compression. And if we make B go back to 1, so we're back to the parent function. Now, if we make it smaller than 1, no, the green point is going away from the y-axis. This is called horizontal stretch. Okay, so let's go here and click enter so that I will get this line here. New line, new row. So I'm going to put a note. I'm going to say that B is for horizontal stretch. And horizontal compression. Yeah, I'll put here vertical compression too. Okay, now let's put B back to 1, to the default. Now H, what does H do? So again, I want you to look at the green point. When we make H equal to 1, the green point moved 1 step to the right. When we make H2, it moved 2 steps to the right. So H is shifting the graph horizontally. If we make it negative, then the graph is moving to the left. See, the green point is moving left and to right, left, right. Okay, so we say that H is for, I need a note. H is for horizontal shift. And now lastly, we'll look at K. K, look at the green point. So when we make K equal to 1, the green point went up by 1. When K is 2, the green point went up by 2. So K is moving the graph up and down. So we call this vertical shift. So let's put a note again. This is K is for vertical shift. Okay, so let's review what these variables do to the graph. So A is for vertical stretching or vertical compression, or if we want the graph to flip over the x-axis. B is for horizontal stretch. So if we want the green point to go away from the y or closer to the y, then we will change B. That's the horizontal stretch or horizontal compression. If we want the entire graph to move to the right or to the left, then we change H. And if we want the graph to move up and down, we change K. All right, so let's move on to slide number 2. Okay, in slide number 2, you are asked to vertically stretch the graph of y equals x by a factor of 3. So because we want vertical stretch, that will be A. We're going to change A. We want the green point to go up to 3. So let's do that. So we have to make it go up to 3. So we just need to make A equal to 3. So now we stretch vertically the line. Okay, so we're done with the first transformation. And then next one is shift to the right 4 units. So horizontal shift. Horizontal shift is H. So shift to the right 4 units. So we have to move H. So that's 1. So that's 1 step to the right, 2 steps to the right, 3 steps to the right, 4 steps to the right. So notice that the green point was here earlier. Now it moved 1, 2, 3, 4. 4 to the right. Then we need to go shift down 2 units. Shift down 2 units. So that's a vertical shift. So we're going to change the K. So we want this green point to go down to 2 steps. So to do that, we will move K to the negative. So my -1 moves it down 1 unit. If we make it -2, then the green point moved down 2 units. So now this is our final line. So now what we're going to do is write equation for this line. And what we need to do is start with the general form, which is a times y equals a times b times x minus h plus k. And notice that I came up, this gave me a graph, and the graph is in the exact place where we brought our line earlier. So that we know that this is the correct form. Now we are going to plug in our a, b, h, and k values. So we'll have y equals, a is 3, b is 1 times, then x minus, we have h is 4, so we put 4, and then plus k. K is -2, so we'll put here just -2. And we know that that is correct because the graph went to this location as well. So now we're going to clean this up. We know that we can simplify this. Okay, this means here inside, this means 1 times x minus 4. So we'll have to apply distributive property. 1 times x is x, and 1 times negative 4 is 4. So now we're going to have to write here y equals 3 times, and 1 times x is x, minus 1 times 4 is 4, then minus 2. The graph of the line gave us, or rather this equation gave us the same line. So we know that this is correct. So now we can still simplify this. What we're going to do is multiply this. So 3 times x and then 3 times 4. So we'll have y equals 3 times x is 3x, minus 3 times 4 is 12, minus 2. And then we'll have y equals, we can simplify this and say 3x. Now minus 12 and another minus 2, that means you have to minus 14. So we'll put here minus 14. And we know that that is correct because our graph, it produced the same graph as the others. Okay, so now let's look at our graph and see if there is something special that we can observe here. If I look at the graph, we see some points that are in convenient locations. So like this one is a nice location because I can determine exactly what the x value of this point is and what the y value is. This is also in a good location because I know the x value here is 4 and the y value is 2. So now I'm going to use these 2 points and okay, I'm going to go from this point to this point. And in order to do that, I need to go up. Okay, I need to go, okay, wait. Okay, I need to go up. Why is this not working? Hold on. Okay, we need to go up. Okay, there. Okay, up 1. Okay, pen is not working. Okay, so 2, 3 steps. So we went up 3. And then we need to go to the right one. So that's a right one. If I get the ratio of the distance I went up and went to the right, then the ratio is 3:1 or 3/1. And 3/1 is equal to 3. Now, do we see this in the equation? Yes, we see it here. We have in our final equation, in simplest form, 3 is right here in front of x. Okay, and then when we start here first. So let's put another line here, and we'll say that we notice that that 3 is in the equation. That is actually called the slope. So we say here 3 is the slope of the line. Okay. And now we're going to look at where the graph crosses the y-axis. So if we go down here, we notice that the graph is touching the x-axis, rather the y-axis right here at y equals -14. Now, do we see this -14 in the equation? Yes, it's right here. So this is the y-intercept because this is where the line crosses the y-axis. So the equation written here reveals to us two important features of the graph, and that is the slope, the one in front of x, and the constant is the y-intercept. So let's put that here. Put another note. Okay, we're going to put another note, and we'll say that -14 is the y-intercept. It is where, okay, let me just write that down, where the graph crosses the y-axis. Okay. So that's it.